community and is now used in diverse applications across the board. SS has always been a real-time server, offering second-level latency with RTMP or HTTP streaming, and sub-second latency with SRT or WebRTC streaming. However, through community feedback, I have discovered that real-time streaming relies on more than just WebRTC. This is a concept I like to emphasize today at Kafka. So many people tend to use WebRTC for real-time live streaming. However, other factors can influence latency, which means WebRTC might not be the best fit for some situations. First, the device or tools used can influence the latency. Sometimes users might not want to switch to a new device that supports WebRTC because they are already comfortable with their current tools and have a workflow that include them. Take OBS or vMix for example. They are popular live streaming tools, although OBS just supported WebRTC. But vMix and many other tools doesn't support WebRTC. Plus, users might have various devices or plugins connected to OBS or Mix, making it difficult to switch to a WebRTC-enabled device. Different platforms also have latency in their ways, using specific protocols. For example, YouTube relies on RTMP or RTMPS. Unity goes with WebRTC, and some broadcasting platforms use SRT. So converting protocols is crucial too. For example, let's say a user has a SRT device but wants to watch the stream on a Unity game or broadcast it to YouTube. I want to share about the SS community. I studied SS back in 2013, about 10 years ago, and it initially supported RTMP, HTTP, and HLS. Then 2 years later, I added support for live stream clusters, and finally, 2 years ago, I brought in support in SRT and WebRTC. Now, if you compare SS to other open source projects, you'll see that Nginx RTMP is mainly a live streaming server, while Jealous and Middlesoap are WebRTC SCPU servers. But SS is for both use scenarios, and SS is actually the most popular project with most stars on GitHub, and it's used worldwide with an active community contributing to it. We learn a ton from our community, especially from the feedback and use cases. They also play a crucial role in shaping SS technology and direction, which helps us keep it moving and improving. In the next few slides, I'll introduce some everyday use scenarios for real-time streaming. The first one is the use case about WIP and WAP. For sub-second live streaming, the simplest solution is to use WebRTC. You can publish your stream with WIP and play it with WAP. This will result in latency about 200 milliseconds. Some developers might be curious about how to publish live streams via Chrome. In this case, WIP is the only known method to ingest live stream from your camera using a browser. If you need to stream your camera through a browser to a video platform that only supports RTMP, you'll need a SFU to convert WebRTC to RTMP. SRS is an example of such an SFU. Once you have converted the stream to RTMP, you can send it to the video platform. Web and WAP are signaling protocols for exchanging SDP between WebRTC clients and servers. Web is the name for publishing streams, while WAP is for playing them. The underlying media transport for web and WAP is WebRTC, which use UDP. SRTP or SRTP is employed to deliver media packets and feedbacks, allowing WebRTC clients to adjust streams and achieve extremely low latency. Sometimes users want to know how to play an RTMP stream from the existing device on web page. This solution requires an SFU to convert the stream to WebRTC. We'll go into more detail on this later. The use case about the publication and blog. When we think about real-time streaming, publication and vlogs often come to mind, with WordPress being a great example. Did you know there are about 1.3 billion websites worldwide, and 1/3 of them are built using WordPress? People use WordPress for blogging, e-commerce, organization websites, product representation, and more. Let me tell you a story about Robin, a video editor. He wanted to share his product design with friends through WordPress because he needed high resolution content that Zoom couldn't handle due to poor video quality. Robin wanted real-time streaming to community about the product design. He chose WordPress because it has many plugins that let him and password protect to the page, so only he and his friend could access it. But there was a problem. WordPress doesn't support real-time live streaming. Robin can only use HLS, which has more than 5-second latency. So Robin joined the SS community, and together we achieved a latency about 1 second. First, he captured and published the screen content using OBS for high definition content and published to SS. Then he used SS Player, a WordPress plugin, to play the content through WebRTC. I can give you more examples. You can use WordPress and SS together to create a video conference, live stream event for WooCommerce, or even make a browser-based live chat room. It's important to know that as a streamer, RTMP and SRT can also be used for sub-second live streaming and not limited to just WebRTC. The use case about Unity game. Unity and Unreal game engine have stream frameworks based on WebRTC. This makes it easy for developers to add real-time streaming to the game. Apart from game, Unity is popular in the creative industry, especially for VR and AR. The Unity WebRTC SDK is an official tool maintained by Unity staff. It helps developers and add real-time streaming to the game. A Unity developer asked questions in the SS community about how to add a Unity WebRTC SDK with SRS. Sadly, the demo doesn't work with OBS or SFU. It only supports P2P communication. This is a big issue for real-time live streaming. Even though it's just a client P2P demo, users want to play the streams from OBS or use a WebRTC SFU server to improve network quality. WIP is an RFC for signaling that's still in draft state, but many WebRTC clients and servers support it, so we can use WIP to fix this problem. When we have worked with Unity developers to add WIP support in SRS and created a demo for Unity with live and WebRTC streaming support. This demo shows how to publish and play streams to SRS, use Unity WebRTC, and interact with OBS through RTMP or SRT stream. Many Unity developers allow using it. For instance, you can use SRS as an SFU server to let multi-Unity clients communicate through WebRTC, or you can use Unity clients to play live streaming from OBS or interact with Unity clients through a web page. For real-time live streaming, it is important to know that web is a key signaling protocol, while WebRTC focuses on video. So emphasizing web is necessary when collecting different systems and projects. The use case about remote broadcasting. The TV and broadcasting industry has more events outside the studio, especially for news and sports. Sometimes you need to switch between multiple cameras, similar to switching between scenes in OBS. But how can you do this remotely? So you don't have to be physically present at every location when news happens. So you can manage multiple events at once from a distance. The demo picture shows how to do this. The left picture represents the news site with multiple cameras, while the right picture shows the output stream with a logo and text. A TV editor receives SRT stream from camera at news site. They remotely access OBS to pull these streams from SRS, switch between them, and then edit them by adding logs and text. Since the latency is less than a second, all the streams are synced, and the TV editor doesn't have to worry about issues caused by asynchronous streams. Another important aspect is that TV often requires HD content, so SRT is better option than WebRTC. And SRT is widely supported by many broadcasting cameras and tools like OBS and Mimix, which TV editors and creators are familiar with. The latency of SRT is around 400 milliseconds, compared to WebRTC's latency about 200 milliseconds. But SRT is also used for long distance transmission and works effectively even under poor network condition. The use case about the audio AI processing, ASR or audio speech recognition, is another scenario for real-time caption, translation, and even controlling AI robots. To add real-time caption to your live stream, you can use ASR. The text generated by ASR can be sent to your AI system for many purposes, like controlling robots and sensors or generating response to questions. You can also translate the text to another language and use text-to-speech technology to convert it back to audio or machine-based interpretation. interpretation. The demo in the picture shows the text generation by the ASR for a live stream. As powered by Key2, the Key2 FSA or Cardi engine is a popular open source project for ASR. You can stream your live broadcaster from OBS to SRs, or use WebRTC to publish to them. Then Key2 will ingest the live stream and convert the voice to text. The latency is crucial, and we have tested the ASR. It introduced about 600 milliseconds latency. So this solution works for many business requires low latency or sub-second latency. Technically, Key2 use FMPAG to decode voice data from AAC to PCM because FMPAG is needed for decoding audio streams. You can publish the stream through WebRTC, and SS will convert it to RTMP for FMPAG. By the way, FMPAG doesn't currently support WebRTC, but we are working on it. Unfortunately, it's a challenging and complex task that might take 6 months or even longer. The use case about 8K HEVC streaming. Sometimes people want to use HDR with 4K or 8K in AR, VR, or MR, but this can affect the latency also. When the resolution goes up, the battery rate increases too. This means more packets need to be sent, and packet loss can be happen, and ultimately makes the latency higher. If you're looking for 8K solution, AVC won't work because it only supports up to 4K. Instead, you should use HVC or 8K for even higher solution. Some developers have tried with SRs to deliver HDR streams with SRT, and they say it works well, but they also mention that the latency is higher. If you're using WebRTC, there might be some solution for 8K, but it seems to be outside of Chrome. This is because 8K affects the latency, which is the main goal of WebRTC. So that's all the use scenarios. If you need a 200 milliseconds latency, like video chat, conference, or remote control, WebRTC is the only option right now. WebRTC is both a transport protocol and an end-to-end solution designed for low latency. This design ensures very low latency throughout the whole system. By default, for WebRTC, B frames are turned off to keep latency low. B frames can refer to future frames, and so it increases the latency. But when it is used, they can make the quality better within the same battery. WebRTC might change the SPS PPS to use different codec parameters, which is small difference between WebRTC and live streaming. So there's a way, and there's always an inserted SPS PPS before each IDR frame. This feature makes the DVR function differently. Usually, the SS PPS stays the same. Letting players play a DVR stream, but with WebRTC, the SPS PPS might change, causing some players to fail to play the DVR file. You might need to transcode the DVR file or WebRTC, but this can cause the WebRTC more expensive. Also, WebRTC always encrypt UDP packets with SRTP, while live streaming can use plain text HTTP streaming or HRS. Plus, the UDP performance is low than TCP because of the scalar is not efficient for UDP packets. These factors can make WebRTC more costly compared to live streaming. Some new video clouds like Cloudflare and Tencent Cloud support WebRTC delivery, but traditional CDNs don't support WebRTC. Sometimes you might need to build your own WebRTC delivery network within your country or company. The last issue, the mobile web browser, especially on Android phones, doesn't support WebRTC well and has many compatibility issues and bugs. Why RTMP is working not LLHRs? The RTMP protocol delivers video frames over TCP for streaming. Similarly, HTTP and HTTPS deliver video packets over HTTP trunk, which is generally the same as a TCP stream. So when you use OBS to publish and stream RTMP stream and SS servers to deliver it, SS will convert the RTMP stream to an HTTP FOA stream. They are both similar to TCP stream, so you can then use the HTML file player to play the HTTP FOA. The whole process is based on TCP stream, with packet delivery in a pipeline similar to a water pipe. Typically, this solution, the latency range from 1 to 3 seconds. And most of the latency occurs on the player side. So if you switch the player to WebRTC from HTML file MSE player to WebRTC player, and the latency will drop to around 400 milliseconds, from 1 to 3 seconds to 400 milliseconds. As shown earlier, even when using OBS to publish an RTMP stream, you can achieve sub-second latency. This is because TCP performs just as well as UDP when network conditions are good. In this case, latency is not caused by the protocol, but by the player. So, for instance, if you use VLC to play RTMP, it will result 10 seconds latency or 20 seconds, even 30 seconds. However, playing HTTP FOA with an HTML file player, like the unpack.js, it will lead to a latency about 1 to 3 seconds. Using a WebRTC player reduce latency even further, about 400 milliseconds. In reality, internet network condition can sometimes be poor. So RTMP is best used in only private network. For example, from server to another server, in a same network. Instead, you can use SRT to publish the stream over internet. Some developers claim that LLHRs can achieve 1 second latency. Unfortunately, this might only be possible in experimental setting due to CDN network server. They have cache time, and players may use different strategies to fetch segments. Moreover, achieve such latency is impossible on the internet because the packet loss in poor network. So you need to conduct a real test to verify the LLHS. In my opinion, LLHS or CMAP cannot achieve the same low latency as RTMP, HTTP/V, or HTTPS. Traditional CDN supports LLHS or CMAP very well, but only a few new with clouds like Tencent Cloud offer support for HTTP/V or HTTPS streaming. Both Cloudflare and Tencent Cloud support WebRTC streaming. When considered sub-second latency, LLHS or CMAP cannot achieve it, but RTMP has a chance to do so in some cases. This is not just for experimental environment, but also for online internet production. So you may be curious about the difference between WebRTC and SRT, which are both built on UDP protocols. WebRTC has a latency of around 200 milliseconds, while SRT has a latency of about 400 milliseconds. Both technologies are great for real-time live streaming and works well with internet-based products. SRT can't achieve a latency of 200 milliseconds or less. So if that's your use scenario, you should use WebRTC. But if you want high quality content, SRT is the way to go. If you are using a broadcasting camera or system for live streaming with low latency, SRT is generally better than WebRTC. This is because SRT is more widely supported in broadcasting devices right now. SRT was created to replace RTMP, so it doesn't have the SPS-BBS issue that WebRTC has. That's why SRT is considered DVR friendly. Also, FMAC and OBS support SRT, but they are still working to support WebRTC. About 2 weeks ago, just 2 weeks ago, OBS also has support for web. Right now, we are currently working on enabling FMPAC to support web, and the PR have been submitted to their community for review. Let me introduce about the SS milestones. In 2013, about 10 years ago, we released SS version 1, which includes support for origin and edge servers, HTTP API, and Trace ID based login. This feature allows you to easily search and find logs for special session using a Trace ID. Many other media servers don't have a good login support for live streaming, which is crucial for debugging because live streaming involves long-term sessions with multiple log lines and concurrency sessions on a server. So, ferreting logger for debugging for a special session is very difficult. We keep improving SRs, and by the time we released SS version 3 in 2019, it supported essential live streaming features like clustering, RTMP, FLV, HLS DVR and forward, as well as HTTP API and callback. After joining Alibaba Cloud in 2017, I worked on WebRTC service. I spent 2 years learning WebRTC. About 3 years about 3 years ago, as I gained significant feature WebRTC support and SRT support. We began building the community about 2 years ago, and it has grown rapidly. Over the past 2 years, the entire community and I have been working together to develop SS version 5 and 6, which include Windows and HUVC support. This slide is about the SS core features. SS supports second level live streaming like RTMP, FRV, and HTTPS, as well as sub-second level protocols such as WebRTC, SRT, WIP, and WAP. SS support HRS, also support HRS, which is a large latency range from 5 to 10 seconds or even higher, offering the best capability for all clients. One of the SS key feature is ability to convert between these different protocols. For example, if you publish content using RTMP through OBS, you can play it on WebRTC through Chrome or on a Unity client. This allows for cross-domain and cross-business video streaming, letting you use popular tools like OBS for sub-second live streaming, and you can use Unity game clients for media streaming. To scale out, SS support Orange and Edge clusters, which can handle millions of clients playing a stream. We are also working on a proxy cluster for WebRTC and SRT. SRT is not just a high-performance media server, it also makes debugging easier. The Trace ID-based logging help you quickly identify bugs and logs. SS use a complex arrow object that includes the stack and variables in the error message, making it simple to understand the root cause of the issue. That's not a common feature in C++ media servers. Additionally, SS offers an HTTP API for querying streams in clients, as well as an HTTP callback for handling events and authentication, like accepting or rejecting collections. SS also include a Prometheus exporter, allowing for direct collection servers from CDN media servers to cloud WebRTC servers. So since I work at Tencent Cloud, I'll compare SS with Tencent Cloud servers TRTC for WebRTC and Streamlink for SRT. SS also supports the standard NAC congestion control algorithms for WebRTC, while Tencent Cloud TRTC supports additional algorithms like GCC, FEC, and AI-based algorithms designed for different use cases. Because SS doesn't perform complex algorithms and doesn't cover color cases, its quality is not good as Tencent Cloud TRTC or Streamlink. However, SS needs to remain simple because SS need to adapt to the entire community's use scenarios, and it only has a small part-time maintained team. SS doesn't build a network that requires resources, scheduling, and balancing, but both Tencent Cloud TRTC and Streamlink have built a global distributed network with a large scale of servers to support the services. If you choose to use SS or another open source media server, you will need to build the network and maintain load balancing. On the other hand, you can create a custom network designed to your needs to host a private network. We intend to build an open source community and non-profit organization for SS, allowing every developer to create a video service for live streaming and WebRTC. Although SS already supports many features, perhaps more than other servers. This is just the beginning. We plan to support even more features, but keep it simple to use. Many developers can't afford paid services because video streaming is only a small part of the business, but it's a significant and important part. Our goal is to empower people worldwide to build a video service that engage their customers and power the business with a high quality, free, open source media server. Because we have a large developer community, some developers might need extra support. So if you need extra support, you can become a sponsor by donating to SRs. Then you can get additional support. We greatly welcome and appreciate your contribution to support SRs. We need the support to pay for essential infrastructures like Docker Hub. It's not free now, and AI tools which assist us in writing better documentations and video tutorials. AI can help us writing correct and fluent documents in English 10 times faster. We also use AI to create video tutorials, significantly improving our efficiency. There's much to do and learn, especially in documentation and communication with developers worldwide. That's why I'm here at ComCon to share SRs. About the SRS license. SRS is licensed under the MIT or Mulan PSL license. It's important to know that the approach license is compatible with Mulan PSL. The Mulan open source community created the Mulan PSL license, which is the first license available in both Chinese and English. Additionally, the OSI has approved this license. The Mulan open source community also supports SS and helps develop and incubate projects within China's startup open source community. Keep in mind that MIT and Mulan PSL license are business friendly. This means you can use SRs in your company or cloud service. So that's all, and I'm delighted to share SRs with all of you. It inspires me and encourages me to think more deeply. I'm looking forward to receive more feedback or even further contributions to SRs. I hope to see you all next time.
Thank you to Winlin. Now, as this was a pre-record, he's not available to answer questions live here, but if you want to get him on Twitter, his handle is @SRS_server. That's @SRS_server. We're into a coffee break now. We're back here at 11:15 when Garrett Graves, self-confessed RTC engineer and AI hacker, is going to be talking about AI and voice in this very room in just 15 to 20 minutes' time. So make sure you come back, and we will now dismiss for a lovely cup of coffee. Thank you.